Hey everybody, Dr. Phil here. This is going to be a video on addressing business questions using business analytics. So let's go ahead and jump right into it. So the first thing I want to talk about is business value and business processes. So business value refers to all the items, events, and interactions that determine a company's financial health. A business process is a coordinated, standardized set of activities conducted by both people and equipment to accomplish a specific business task. And obviously, any business is just, when you think about it, just a series of processes that repeat themselves. Companies perform thousands and sometimes millions of processes each day to create business value. So some examples could be, DoorDash. It's got to pay its drivers who are 1099 employees, independent contractors to make deliveries. Obviously, Tesla produces electric vehicles to sell in China, and then P&G, Procter and Gamble, addresses customer complaints sometimes by giving refunds. These are all things that are happening, kind of over and over again, if you will. So it doesn't come as a surprise to any of you, I'm sure. The availability of data is just kind of skyrocketed, kind of exponentially. If you look at it since 2010, you look at what it is now, you can see that it's grown substantially, right? So that's why we have like data warehouses, all these big repositories, if you will, of places to put data. So what is a business analyst? So we could think of this as a data specialist who curates and uses data to help an organization make effective business decisions. So you gotta know where the data is. You gotta know how to mine the data, right? Because the data is only as good as the data that's put in, like garbage in, garbage out kind of thing. It's also important to understand that if you don't know how to mine the data, you may not be able to extract a lot of value from it. So data helps and hinders the analyst role. And this is certainly the case. So it helps because the more data, then technically the more data-derived insights for decision making. That's true. I agree with that. However, it can be a hindrance because the increasing amount of data may hinder the work of the analyst through what we call data overload. I'm sure you've all heard the expression like TMI, right? Too much information, where too much data may not be properly synthesized or interpreted. So here we see like the what we call the information value chain. So we have the data. You can see here the raw facts that have, in and of themselves that are they don't really mean anything. The context is the setting, the event, the statement, or the situation. So maybe that could be like the business problem. The information, data organized in a way to be useful to the analyst or user, combining data with context. That's kind of what we're looking to do. We're looking to combine these two. Knowledge, understanding, or familiarity with the information gained. You got to obviously understand the output, otherwise it's not really going to help you. And then decisions, excuse me, decisions, conclusions reached after consideration of knowledge is considered. So, and that's kind of the crux of this, right? Decisions is like, if you're not going to use it to make decisions, then, why are you even doing it in the first place? So here's an example using Tide Pods. So we've got the same sort of graphic up here, right? So the data is a data dump of Instagram posts. The context is Instagram posts regarding Tide detergent pods. The information is the current level of consumer sentiment regarding Tide Pods. The knowledge is the knowledge of current and planned marketing campaign and consumer response on Tide Pods. And then the decision is decisions regarding future marketing campaign of Tide Pods. So that makes sense. So who gets involved with data? Well, a few people. The decision maker needs knowledge and information to make decisions. So that could be a manager, maybe like senior managers. The data scientist is a specialist who knows how to work with, manipulate, and statistically test data. And then the business data analyst is kind of the go-between, if you will, the interpreter or liaison, as it says, the one that knows business, knows what data is needed, and knows how to communicate with both the decision maker and the data scientist. So the data scientist and the decision maker kind of maybe speak different languages. So it's, think of the data analyst, that business person as kind of the go-between. So yeah, as it says, right? So you've got your let's start on the right. So you've got the data scientist over here. This is the developer. You've got the business analyst in the middle. This is the interpreter. And this is how the decision maker is able to actually understand what all the data means. So business analytics can be defined as the use of data to create knowledge, to help draw conclusions, and address business questions. Different business functions have different business analytical needs, obviously. Marketing needs are different from financial analytics because we're looking at different things, obviously. Accounting analytics are different from operations analytics. So let's talk a little bit about each one of those. So let's start with marketing analytics. So marketing is the act or business of promoting and selling products or services, as I'm sure you're aware, sure you know. Marketing analytics measures and attempts to improve its marketing performance. So, arguably, the most important component of marketing analytics is providing insights into customer preferences and trends. So, it's like using all the data we have in this big warehouse, big, repository to actually draw some meaningful conclusions, perhaps some business strategies about how we can, market better and ultimately sell more. Now let's look at accounting analytics. So accounting works to measure, record, and communicate financial performance to decision makers, including shareholders, management, customers, suppliers, and regulators. Now, accounting analytics use business analytics to help measure accounting performance and address accounting questions in the audit, financial accounting, managerial accounting, and tax areas. And there's perhaps other ones as well. Financial analytics is, think of this as the management of money, which this is finance in general, right? The management of money by investing, borrowing, lending, budgeting, saving, and forecasting financial capital, money. So financial analytics we're going to use this idea of business analytics to help a company measure and evaluate its financial performance, from predicting receivables collection. So the receivables is money that people owe you from its customers, to helping management evaluate future investments based on expected investment performance. Such returns to investments in equipment or employee training, or perhaps even stocks and bonds. So kind of anything finance related, would fall under that purview of financial analytics. Now, operations analytics. So operations includes an evaluation of a company's human resource. So think of HR, evaluation of employee efficiency and turnover. Could be a couple of examples for that. IT operations, supply chain, for example, sourcing, manufacturing, distribution, and logistics. Operations analytics measure and improve the efficiency and effectiveness of the company's operations, since operations is all actions needed to run the company and, of course, generate income. So getting the right product in the right place at the right time requires extensive data analysis to ensure product fulfillment. And then the next thing we'll talk about is what we call the SOAR model. So this is an acronym. So S in SOAR stands for specify the question. So different questions lead to different analytics types. So the 5 general types of business questions and their respective analytics type are as follows. So these are the 5 types of analytics. So descriptive analytics, i.e. what happened. Diagnostic analytics, why did it happen? Predictive analytics, what is likely to happen in the future. Prescriptive analytics, what actions should we take based on what we expect will happen. And finally, adaptive analytics, how does the system adapt to changes? And then the O in SOAR stands for obtain the data. So which data is available? Which data needs to be collected? Will the data actually adequately address the question? Is the data relevant to the question being asked and/or reliable enough to address the question? Is it clean of errors or inconsistencies? Does it have lots of missing data? That can be a problem. There are statistical workarounds for that sometimes if there's not too much missing data. And is the data biased in some way? That could be a problem. So we can kind of see in exhibit here the ascendancy model based on the SOAR model. So you can see descriptive, what happened. In this case, what is the average age of our customers? Diagnostic, why did it happen? Why did shipping time increase? Predictive, what is likely to happen in the future? So, for example, what is next year's demand? Prescriptive, what actions should we take? Keyword there is being should. Should we make or buy the product? And then adaptive, autonomous, how does the system adapt to changes? In this case, how should the marketing strategy change? And notice, as we're sort of moving from left to right, hindsight, insight, foresight, and right sight. So now the R in SOAR stands for report the results. So what's the best way to communicate what we found in our data analysis? And there's different ways we can do that. Static visualizations such as reports, graphs, and tables. Think about programs like Tableau that have kind of come into their own in the last few years, like this idea of like data visualization. And then also dynamic visualization such as dashboards. A lot of companies kind of keep their key metrics. There's obviously a lot you got to know, but like what are the key things that we need to be constantly monitoring to help us run this business? So just to recap, number 1 of the SOAR model, specify the question. Number 2, obtain the data. Number 3, analyze the data. And number 4, report the results. And this is, of course, just iterative, just keeps going round and round and round. And the last thing I want to talk about in this video is data visualizations. And I kind of touched on that a second ago in the lecture. So these are defined as graphic representations of data, usually in the form of a graph, chart, or other image. So there's 2 types, there's exploratory and there's explanatory. So exploratory data visualizations are useful for uncovering patterns and useful insights in the data, generally as part of descriptive or diagnostic analytics. This is part of the analyze the data step of the SOAR model we discussed, the SOAR analytics model. And then we have explanatory data visualizations, important means of reporting the findings of the business analytics to stakeholders. And this is part of the report the results step of the SOAR analytics model. So again, explanatory, typically, it's stuff that's already happened. Exploratory potentially could be more, things that we would like to see happen in the future. All right, thanks for watching the video, and I will see you all in a future video.